Hola, mi clase. So we are going to 3.4 today, and it's about arithmetic sequences. Okay, so I can write the recursive and explicit formulas for an arithmetic sequence. So then we have these key terms. Well, a sequence is an ordered list of numbers that often form a pattern. So they have a pattern. It's kind of like when you were younger and you would like say, oh, they skip, jump, skip multiply by twos, or they add two every time. You just kind of have to find the pattern. The difference is we're going to actually write equations for them. So a term of a sequence is whichever number in the sequence it is. So is it the first number in the sequence? Is it the second number in the sequence? It would be the term. So if it's the fifth number in the sequence, it would be the fifth term. Okay? An arithmetic sequence is a number sequence formed by adding a fixed number to each previous term to find the next term. So arithmetic is with adding. So it means from one number to the next, we're going to add a specific number. Okay? And then a common difference is the fixed number or difference between the consecutive terms of an arithmetic sequence. So the common difference is the number that we're adding. It's that fixed number in between them. Okay? So we'll use these words while we do the lesson as well. So here is a list, an ordered list. So it's a sequence, and it's telling us it's an arithmetic sequence, which means we're going to be adding something in between each, right? So the n equals the term number in the sequence. So n could be any term I want it to be. That's why it's a variable, right? That's what a variable does. And so if I want to find the 20th term, I would need the n being 20. And then let a to the nth, or a to the nth, is the value of the nth term of the sequence. So it's kind of like that function notation where when we had the function of x, it was the function at, 2 is what's the function when you plug in 2. This is very similar. So it's the value of the 10th term is whatever. The value of the 8th term is so-and-so. So in this case, if we're looking for a to the first, we're looking for the first term, right? Because that's what that n stands for. And so the first term in my sequence is 26. So a to the first would be 26. Another way they write it is this little a to the 1, what we call a subscript. It's like an exponent, but it's below it. So it's the same idea. So a to the 1 is still the first term. We can write it like this. Okay. And then, so a to the second would be the second term right here. So it'd be 39. And then again, they write it sometimes like this. It's the same idea. It's 39. Okay, and then the last one is asking us for the sixth. What's the sixth term, right? That's why it's a 6 in here. So we would count 1, 2, 3, 4, 5. Oh, what's the sixth term? Well, we would then have to figure out what this is moving by. So if we look from 26 to 39, what did I add here? Okay, so 6 plus what is 9? Well, that's 3. And 2 plus what is 3? So it's plus 13. So if I check the next one, is it going to be plus 13 to get to 52? Well, 9, 10, 11, 12, and 3, 4, plus that extra 10, yep, it's 52. So my adding in between each is 13. So since this is my fifth term, right, 1, 2, 3, 4, 5, I'm going to take my 78 and add that 13. So 8, 9, 10, 11, and then 7, 8, 9 because of that 11, and so a to the sixth term is 91. All right, so remember, arithmetic means I'm going to be adding. An arithmetic sequence means an order of numbers that I add something to them. Okay, and then we would call this the common difference because that's how much they're changing by. It's a common thing happening over and over and over again. So remember in the beginning we had listed, it talked about a recursive formula, and an explicit. So this is a recursive formula, and it is an arithmetic sequence. Is we take our first term, a to the 1, and then we have to list it. All right, so we would have, what is a to the 1? And then we would do the nth term of the sequence is a to the n equals a to the n minus 1 plus d, or that common sequence, okay? That common number. Sorry, spacing out. So our formula would then be for this same sequence, right? So we list our first term. So we go a to the 1 is 26. And then we go, well, then a to the nth will be a to the nth minus 1, so the term before it. So if I had a to the second, I need to go one term before it. Here it is, 26. And then I would take my common difference. So now if you remember from on the last page, the common difference from here to here, the last example, was 13, right? Our common difference, I'm going to put C, D, common difference was 13. So then we would go plus 13, because that's our common difference, what they're changing by. Okay? So what that does is it allows us to then find different ones if we need to. Okay? Now we would always need the one before it. So if I asked for a to the, the third, what's the third term? I would have to go find the second term and then the first term, right? I would have to go find them before I could get there. Okay, so that's the one problem with recursive, is I need all of them before I can get to the one I want to, okay? Because I need the number before it, before I can get to it, okay? So this is recursive. We always list our first number and then we list our common difference. Now, an explicit is a little different. It expresses the nth term of sequences in terms n, where the explicit formula is then this sequence. So a to the n is, I actually fill in my first term. I'm going to use it now. And then we go, what term I'm looking for, minus 1 times the common difference. So it's a little different, okay? So we still need our first term, and we still need our common difference, okay? So here's our first term. This is my a to the 1. Our common difference was still 13. This is the same sequence that we've been using. There's my common difference. So if I need a to the n, I'm going to go a to the n equals, well, a to the 1 was 26 plus n minus 1. That's whatever next term it is. So if I was looking for the fifth term, it would be 5 minus 1. This time I'm going to multiply by my common difference. Now, thankfully, we've done distributive properties, so I'm actually going to distribute this 13, and we're going to get a to the n equals 26 plus 13n minus 13. And then I'm going to clean this up, and I'm going to do 26 minus 13, and we're going to get a to the n equals 13n minus 13. And that's your explicit formula. What's really nice about the explicit formula is I don't need the term before it or the term before that. I just need to know what term you're asking me for now. So if I need the 20th term, I really want an explicit formula. Now, if I want, maybe the 6th term like this would be a little easier because I have all of those. Okay, so recursive, you really only want a recursive if it's close, right? But explicit allows me to find any one I want. All right, so the cost of renting a bicycle is given in the table. How can you represent the rental cost using an explicit formula? So remember, that's the one we just did. A to the n equals a to the 1 plus n minus 1 times my common difference. So these are my terms right here. This is first term, second term, third term, fourth term, right here. So why don't you see if you can find the common difference? Let's go find that common difference, or where they just like the letter D. And then list what the first term is. Let's start there. So let's see if you can find the common difference and just list the first term. So we should have said the common difference was 12 and that my first term was 26. Okay, that's because from here to here it's 12 and that's my first term. Okay, so now take that information and see if you can fill it into our explicit formula and write the explicit formula. Pause, try it, and let's see if we get the same thing. So we should do a to the n equals 26 plus parentheses n minus 1 times 12. And then we should have distributed here by 12. So we get 26 plus 12n minus 12. Clean it all up, and we get a to the n equals 12n plus 14. And there's your explicit formula. So main things is what is A1 and what is the explicit or the common difference. Those are the main things we always want to look for. So this says we have a recursive formula for the height above the ground of the nth step of stairs is shown here. So we have a to the n equals a to the n minus 1, right? The term before it, plus 4, with a1 being 7. We want to write the explicit formula for this. Okay, so if we go back to our recursive formula, I'm going to go all the way back. Remember, we listed our a1, and then the common difference was added. So if I look at for my information, they gave me my A1, and there's my common difference, right? That's my common difference. So if we're going to write an explicit formula, I'm going to go a to the n equals my A1 plus n minus 1, and then times that by that 4. So that's how you can flip recursive and explicit. It's all there for me. If I have the recursive, I can write the explicit. If I have the explicit, I actually could write the recursive. So we are going to distribute. We got to clean it up. I'm going to come down here. I feel like I'm out of room. I'm going to come over here. A to the n equals 7 plus 4n minus 4. And then our final explicit formula would be 4n plus 3. Now, the whole point of that is so we can then use it to find other things. So this wants to know what is the height of the stairs at the 20th step, a to the 20. So what that looks like is we're going to use this explicit formula. So I'm going to go I'm looking for the 20. So I'm going to go 4 times 20, that's my n. Remember, this stands for n, this stands for n, plus 3. So we get 80 plus 3, and we get 83. So a to the 20 is 83. And that means it's 83 whatever. I don't know if it's feet or inches. I'm assuming if it's steps, it's probably feet. But there's how we then use our explicit formula. Okay, so here's your independent practice. You are being asked to write the recursive and the explicit formula, and then find me a to the 12. I'll give you a hint. Use the explicit formula, not the recursive. All right, adios until next time.